Okay, the video for some reason stopped partway through, so there are a couple more problems I want to finish up here. The next problem on our note sheet was the one that said the log base 0.4 of 12 equals x. And this one has a decimal, but that doesn't change anything about the way we do it. So we'll say 0.4 to the x equals 12. And then we'll take the logarithm of both sides. So we have the logarithm of 0.4 to the x equal to the logarithm of 12. The exponent's going to come off in front, so x log 0.4 equals log 12. Remember, that's one of our properties of logarithms that we talked about last week. And x is going to end up being the log of 12 over the log of 0.4. So I can type that in on my calculator and get my answer. Now at this point, let me get the answer here first of all. Negative 2.7119 is our answer. At this point, I'd like to make an observation, and since our tape stopped and we moved on, I need you to look back at what happened on your note sheets to the last few problems that we've done. Problem A, which looked like this, ultimately, after we went through all the steps, ended up being the log of 4 divided by the log of 3. And problem B, after we went through all the steps, ended up being the log of 11 over the log of 7. And this one ended up being the log of 12 over the log of 0.4. So maybe you've made the connection that when we do the next problem, log base 29 of 3, the answer is going to work out to be the log of 3 divided by the log of 29. If you made that connection, you are exactly right, because it's always the log of this number over the log of this number. Earlier in the part of the tape that got cut off, a student said, hey, if you just kind of draw a line along there and put another log down here, that will be your answer. Log 3 divided by log 29. That's a great way to think about it. If that works for you, use it. It's actually called the change of base formula, and it will work every time. So if we're doing the log base 5 of 18, using Jack's idea, we'll just draw a line across there, and we'll do the log of 18 divided by the log of 5. And we'll type that into our calculator and get the answer. And then the next one, which is the log base 2 of 90, we can do the same thing. That will just be the log of 90 divided by the log of 2. Now kids, if you prefer to go through the steps, that is a-okay. That's never going to be a problem. Go ahead and go through the steps. But if you don't want to go through the steps, this will always, always work. This will always be the log of 12 divided by the log of 0.4. Always, always, always. Okay, now we need to look at one problem from our book. So we will look at number 54 on page 318. We're looking at problem 54 on page 318. And that problem uses a formula that they give us. Looks kind of scary, but please do not be afraid. There's the equation they give us to do this problem. Now, there are two variables in this equation. There's an I, which stands for intensity in lumens. And there's an X, which stands for depth in feet. So if you read the problem, they have to give you a piece of information. So you plug in. You're either going to plug something in for I, or you're going to plug something in for X. So which is it? Well, let's read the problem and see. There's a 10 feet mentioned in the problem. What do you think we're going to do with that 10 feet? We're going to put it in right here because it says a depth of 10 feet. We're going to put it in right here. So we're going to have the log of I over 12 equal to negative 0.0125 times 10. which is negative 0.125. Now we need to solve this equation. Remember, you have to get rid of that logarithm. You're going to need to rewrite this problem. The base is an understood 10. So we'll say 10 to the negative 0.125 equals I over 12. 10 to the negative 0.125, and remember when I type that in on my calculator, it's 10 raised to the negative 0.125 power. And that number is 0.749894. And that equals I over 12. So to solve that, we're going to multiply this number times 12. So just hit times 12 and end up with I equaling 8.9987 lumens. And that's it. I'll see you tomorrow. Have a great afternoon and evening.